Here's a system of 3 equations and 4 variables. Let's write this as a matrix. Remember to put 0 where there is not a variable in the equation. This bar separates variables from the solutions. It's useful to distinguish augmented matrices. Start with the number in the upper left. If it's a 0, you may have to swap rows to get a non-zero entry here. This will be our first pivot. We want each entry below this to be 0. Row 2 is a freebie, but to get 0 in row 3, we'll need to add row 1 and row 3 and replace row 3. I'll denote that by writing R3 plus R1 arrow R3. This tells me exactly what operations I'll be doing so I can check my work later. It's also telling me that the only row I'm overwriting is row 3. We do not want to overwrite the pivot row. We want to use the pivot to make zeros. Carry out the operation. Rows 1 and 2 are unchanged, so we can just rewrite them. Row 3 is replaced with the sum of the old row 3 and row 1. Be careful here. The most difficult part of linear algebra is basic arithmetic, and I'm not exaggerating or joking. If your final answer differs from a solver or somebody else's, check the arithmetic first. This is why I carefully label my steps. Much easier to trace through and find an error. We found the pivot in row 1. Move to row 2. Find the first non-zero entry. This will be our new pivot. We want to make 0 above and below this entry. We'll take 3R3 plus R2 stores R3, and R1 minus R2 stores R1. I could have divided row 2 by 3 first, but in general this might make fractions, and the arithmetic is already hard enough. I try to avoid fractions until the very last step. Carry out the operations. Notice we have a row containing only zeros. This is fine. If we had all zeros except the last column, it would mean there is no solution. Make the pivots be 1. Let's rewrite this matrix as a system of equations. Column without pivots are free variables, and each column represents a variable. The first row gives x1 minus 7x2 plus 6x4 equals 5. The second gives x3 minus 2x4 equals minus 3. And the third gives 0 equals 0. x2 and x4 are the free variables. Let's find out what that means. Solve each equation for the pivot. Notice there's only one pivot in each equation. That will always happen. Since x2 and x4 are free variables, they can be whatever they want to be. Let's say x2 is 2 and x4 is minus 1. Then x1 is 25 and x3 is minus 5. Plug these into the original equations, and we'll see this is a valid solution. Any numbers you pick for x2 and x4 will work. That's why they're called free variables.